Here is the formula for integration by parts, and this will be given to you in your formula book. The formula shows you that you have two distinct functions multiplied together inside the integral symbol. So you have a u and you also have a dv/dx. Now, part of your job is to choose which function should be u and which should be dv/dx. There is a trick you can use to help you choose which function should be u, and that is the LATE acronym. LATE stands for logarithmic, algebraic, trigonometric, exponential. And you choose your u function in that order, running top to bottom. I'll show you how that works in the examples now. Example 1. Use algebraic integration to show that this is true. So first of all, we can identify that it's integration by parts because we have two distinct functions multiplied together. We know from the integration by parts formula that we have to choose one of those functions to be equal to u. So we think about that LATE acronym. And here we've got an algebraic expression, 5x minus 4, and also an exponential expression, e to the 3x. Because a is above e, we're going to choose the algebraic expression to be u. So underneath, we're going to say u equals 5x minus 4, and therefore dv/dx is the e to the power of 3x. Once we've chosen, then we have a look at the formula, and we can see that we're going to need to know u, v, and du/dx. So underneath the u, let's find du/dx, which is 5, and underneath the dv/dx, let's find v, integrating, so 1/3 e to the 3x. Now it's just a case of carefully putting those expressions into the formula. So first of all, we've got uv, so 5x minus 4 times 1/3 e to the 3x, minus the integral of v times du/dx. I would leave the first part as it is and focus on integrating that expression there. So because it's 1/3 times 5, that's like 5/3. And therefore, when we integrate this expression, we're going to get 5 over 9 e to the power of 3x. Because there, I'm also dividing by 3 because it's e to the power of 3x. So I'm dividing by the derivative of 3x. I've made another video on that trick, so you could have a look at that as well if you want. Now, I haven't put plus c here because I know that this is a definite integral and I have limits to sub in. So at this point, I'll use big square brackets and put my limits in there. And then we just need to sub in those limits as we normally do. And if you do that bit by bit, you're going to get this 1/3 e to the power of 3 minus 5/9 e to the power of 3 minus 4/3 minus 5/9. If you tidy that up, you get this, which is the same as the expression they wanted in the question. So we're done. Example 2, find the integral of x squared e to the x with respect to x. Once again, that's two functions times together. So it looks like integration by parts. Want to choose our u function first, and we've got algebra or exponential. So again, algebra comes out on top. Therefore, let's say u is going to be x squared and dv/dx is e to the x. We differentiate this one to get 2x, and we integrate this one to just get e to the x again, stays the same. We sub into our integration by parts formula, so uv, first of all, minus integral of e to the x times 2x. And now here's an interesting situation because inside the integral, once again, we have two functions times together. So this can happen, and all it means is that you have to do integration by parts again. So looking at the two functions we have here, exponential and algebraic, looks like we should choose the algebraic one to be u again. So underneath this, I would say u equals 2x this time, and dv/dx is e to the x. du/dx therefore is 2, and v is e to the x. Now, just got to be really organized with this. So I'm going to copy down the x squared e to the x from the line above, and then I'm going to do a minus, big brackets, and then do this integration by parts formula here. So uv, 2x e to the x, minus integral of e to the x times 2 in this case. So I'll just stick the 2 in front, close brackets. Now, that's the same as x squared e to the x minus 2x e to the x. And then just being careful of that double negative there, minus, that's going to be plus 2 e to the x when I integrate that. Plus c this time because it is an indefinite integral with no limits. And that's it. Last example, find the integral of ln x dx. Now this is actually a special case, and it's almost a proof that you can learn off by heart. The reason this is a special case is because technically we don't have two functions or expressions multiplied together yet. However, the trick is you can say that this integral is the same as the integral of ln x times 1 dx. And if you do that, then you are identifying that there are two distinct functions or expressions times together here, which means we can use integration by parts. Looking at the late acronym to choose u, we do in fact have a logarithmic expression, ln x. So in this scenario, u can be ln x, and therefore dv dx is 1. And then you just do it as we have been doing. So du dx, we know how to differentiate ln, that's 1 over x. We know how to integrate 1, that's just x. And therefore, when we sub into the integration by parts formula, we get uv, so x ln x. I've just written it that way around here because I think it looks neater, minus integral of x times 1 over x dx. Now that's good because these x's will cancel out. So we're left with x ln x minus the integral of just 1 with respect to x, which is pretty straightforward. So x ln x minus x plus c. So now we know that the integral of ln x is x ln x minus x. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.